So your teacher wants you to visit the Museum of Human Disease. What can you possibly want to see here? Apart from the obvious, we have cysts and polyps, itises, omas and isms. We have lungs and livers and spleens and feet, skin that itches, heads that ache, bones that broke and hands that shake. A 6 centimetre elbow horn, a tumour with hair and teeth, tiny hearts and giant kidneys. Diseases of now and disease from before. Terrible, horrible, nasty diseases. Some are mine. Which is yours? The only museum of its kind in Australia to welcome the public, your visit is a truly unique experience. More than 2,000 specimens of diseased human tissue show exactly what infectious and non-infectious diseases do to the body. Learn the causes, symptoms, treatments and preventions for global killers. Particularly relevant to senior biology, science and PDHPE students, the museum provides in-depth resources specific to the syllabus, including worksheets, videos, computer tutorials and video conferences. Plus, we've created exhibits in the museum especially for visiting students. Medical technologies, bionics, vaccines are just a few of our specialised topics. While you're here, you'll be able to talk with experienced museum education officers, as well as museum volunteers. The museum is at the University of New South Wales, so it's a perfect opportunity to check out uni life while you're here. And since most of our volunteers are actually science and medicine students at UNSW, we're more than happy to chat with you about your course and career options. Here's what other students thought about their Museum of Human Disease visit.
I thought it was really informative. You go around and you see a lot of things that you recognise.
Probably the black lung from the coal mining.
That could be me, or that could be a part of me.
Because it looked gross.
See all the things that you can catch or die from and then take preventative measures to avoid it.
Yeah, the forensic part was actually probably the best part.
You don't really need to smoke, so...
Know your enemy.
You will see specimens showing the effects of tuberculosis, antibiotics, the immune system, smoking, drinking, drugs, travel and genetic faults. Stories to scare your parents, to help your friends and let you avoid the traps for young players in the fight for a healthy life. They are all here in living colour.
In the Museum of Human Disease, we have all the body parts and we tell kids and all other kids what it's about of human disease.
John Douglas is an artist, educator, arts worker, and now the artist in residence at the Museum of Human Disease. He also suffers from kidney failure and juggles his heavy workload as an artist with regular dialysis treatments.
I have about 10% renal function left in my kidneys. I contracted renal failure about 7 years ago.
The kidneys normally filter the blood in microscopic structures called glomeruli, which are small networks of capillaries. Blood moves through the glomerulus at very high pressure, and molecules that are small enough pass through the capillary wall into the Bowman's capsule. John has a kidney disease called glomerular nephritis, which causes damage to the glomeruli. People with this disease can develop kidney failure and require dialysis to remove toxins and nitrogenous waste from their blood.
I have a condition, it's a fairly rare condition because it usually happens with children, called glomerular nephritis. And the only reason that I was able to diagnose that condition is that I did become partially blind in one eye. But I was just getting a few headaches and vision disturbances, and I wasn't really prepared for the fact that my kidneys were failing.
There are two types of dialysis, hemodialysis and peritoneal dialysis.
Hemodialysis is where, first of all, you have surgery to create a fistula in your wrist where they join an artery and a vein together. And then large needles are then injected into that vein once that fistula is formed after a couple of weeks. And the blood is taken out and passed through a centrifuger, so it kind of works, it kind of spins the blood around and takes all the fluid and the toxins out that way. Then the blood is pumped back into the body.
So, to actually highlight some aspects of surgery, I'll show you one picture. Can you tell me what you guys see in the picture?
Doctors.
Yeah, doctors.
Surgery.
It's a surgery, exactly.
Face mask.
Mask. Yep.
Scalpel.
Scalpels. Yep. Now, can someone tell me what the doctors are wearing? The blue sort of, I'm not sure what to call it, but the blue thingy they're wearing across their shoulders and on their head. Can someone tell me what that is?
Clothes.
Coat.
Yeah, it's a form of clothes that the surgeons actually wear. Now, the surgical gown is important for many reasons. Can someone tell me from Hennessy High School why doctors wear the surgical gown during an operation?
To prevent infection.
For the doctors or for the patient?
For the patient.
Both, exactly. I mean, in this day and age, you hear people with bloodborne infections like HIV, hepatitis C. So if the doctors do not wear protective equipment like gloves, you see, if you look at the hands in the bottom of the picture, you see doctors are holding all the medical instruments, whatever they are, and they're wearing gloves. And all of them will be wearing 2 layers of gloves at least. Now, this is to protect the doctor from any infection or viruses that can, literally reside in the blood. And at the same time, it protects the patient because you do not want bugs, around the doctor to enter the patient.
So, just to simplify things, we'll just look at a schematic diagram. So, Williama, could you identify the top layer of skin for me?
The epidermis.
That's right, great. So that's the epidermis. So on the top of the epidermis we have these dead cells which are firmly attached to each other, and we've also got these keratin fibers. So that's that tough material which also make up our hair and our nails as well. So these features actually make the skin quite waterproof, and they protect the underlying cells from abrasion as well as chemicals and microorganisms from the external environment. And it also helps to prevent any uncontrolled water loss from the body as well. So you can think of the epidermis as like a durable overcoat for the body. And we've also got continuous shedding of those dead surface outer cells as well. So that removes any of the microorganisms that do manage to stick to the skin, and it protects against infection as well. But of course those cells are continuously being replaced by those underneath. So we're not just losing skin. The average person, you might want to know, actually sheds about 18 kilograms of these dead skin flakes. So that ends up as dust around our homes and in the vacuum cleaner bags as well. So just think about, that. Identify this structure, or this layer of skin beneath the epidermis for me.
Dermis.
The dermis, did you say? Good. Yep, so that's the dermis. So the dermis binds the entire body together like a body stocking, and we've got these connective tissue fibers. So you can see just a close-up of a human slide there, human skin slide, and these fibers make the skin really strong against most jabs and scrapes, and some of these fibers also bind water, so that helps to keep the skin hydrated and flexible as well.